All right. So now we're at number 15. So number 15 says that we have a beam of light emerges from water into air. So it's going to go from more dense to less dense. So that tells me it's going to bend away from the normal. Okay, number 16. Number 16 says, a rainbow nicely illustrates an example of light reflecting and reflecting. Reflecting because it's total internal reflection, and refracting because it's dense. Okay, number 17. Number 17 says, suppose you hold a converging lens in front of a window. Okay, so here's my converging lens, here's my window. And there's a tree out here, and there's a car, and there's some people walking toward the car, and that's in front of the lens, in front, and so your hand is over here, and the image forms on your hand, and so it says the focal point of the lens is located at your hand. So from here to here, that's exactly what we did in the lab when we found the focal point of the lens. All right, number 18. Number 18 says that a person's eye cannot form a sharp image at a distance if the person is nearsighted. So they can see things up close, so we call them nearsighted. If they do not have vision for objects far away, so we say they don't have any far vision. They only have near vision. We call them nearsighted. Number 19, where do the eyes of a nearsighted person focus light? In front of the retina. And this is done on that worksheet that I gave you Friday that I asked you to have ready for today. Or tomorrow, if I'm going to see you tomorrow. Okay, that should say number 20, but you can see that it's numbered goofy. So it goes back to number 1, which is kind of odd. Okay. Farsighted people need to wear glasses that contain convex lenses. So they can bring the image up onto the retina. The second thing says when you use light from a distant object to determine the focal length of a converging lens, what are the characteristics of the image formed? Well, we did that with the lab. It was smaller. It was inverted. It was real. Okay. Number 3 says when light travels from an optically dense medium into a less dense medium, we know that the speed of the wave increases, so it's a less dense medium. Which is answer choice A. Okay. Let's go on to number 4. Number 4 says a beam of light emerges from water into air. What happens to the speed of the light? Same thing there. As number 3, it increases because it's in a less dense medium. Okay, the 5th one says why are ray diagrams useful? They help us determine four characteristics of an image. And that way, if we know how to do a ray diagram, we don't sit around and memorize things. We can figure it out first. Okay, number 6 says, how is a mirage formed? Okay, and mirages are formed from light traveling through different temperatures of air. So mirages are formed when light travels through layers of air at differing temperatures. Okay, number 7. What 2 conditions must be met for total internal reflection to happen? So it must be going from, let's say, light moves from more dense, medium, to less dense, medium. Okay. And the second condition is that light must shine at the critical angle. The incident at the critical angle. Okay. Alright, Snell's law, N1 sine theta 1 equals N2 sine theta 2. This side is always the incident side. This is always the refracted side. Alright, so now we need the definitions. So the focal length. From the lens to the focal point. Two says focal point, and that's the point at which rays passing through the lens parallel to the principal axis. Must intersect. So if this is my principal axis, and this is my lens, and again, I'm not very good at this because it's kind of hard to do on this tablet. There's my parallel. Comes on there, goes to the focal point. There's my focal point. And if I took one from the bottom and did it parallel, it would also go through the focal point, which I can't draw. Alright, the third one is the real image. Image formed by actual intersection of light rays. Okay, it can be cast upon a screen. We saw that in lab. It's always going to be inverted. And what else do I want to say? Oh, it's a opposite side of lens. Virtual image. You saw this in the lab. It cannot be cast upon a screen. It's always going to be upright. You have to force light rays to intersect to make it happen. And SSO, well, same side of lens as the object. Okay, refraction is just the bending of light as it moves from one medium to another. Okay. HI is image height. I'm going to stop there, and then I'll start another one.